Hello, my dear students. This is the lecture number 2 for current electricity, and now today we are going to see what is Kirchhoffs laws. So, Kirchhoffs laws basically we are going to learn to solve the numericals. By using these Kirchhoffs laws, we can solve any complicated network, any kind of network we can solve. Not easily, but yes, with some procedure, we can definitely solve such a circuits by seeing such a laws. So there are only two laws given by the scientist Kirchhoffs in 1824 and 1887. So by learning these laws, we are going to solve number of numericals which will be useful for your board exam as well as CET, NEET, JEE. So by practicing these examples, you can solve any complicated network. So before going to learn these two laws, you should know some basic concept regarding the circuit, that is nothing but junction, loop or mesh, branch and node. So let's see one by one what is junction. So junction is any point in electrical circuit where two or more conductors or wires meet or join together. So this is explained in the example. You can have a look in diagram where junction is shown where two or more than two branches are made together at a point. Now second one is the branch. Branch is any part of electrical network which lies between two junctions. Branch can consist of resistance, capacitor, inductor, voltage source, current source, etc. This you can have a look in a diagram. Now third one is nothing but a node. Node is a point where two wires meet. Two wires or conductors meet at a point. This is known as a node. And the last one is nothing but loop or mesh. Any closed conducting path in an electrical network is called as loop or mesh. You can see in diagram. So to form a loop or mesh, closed circuit is necessary or closed path is necessary. Until and unless it is a closed circuit, you cannot form a loop or mesh. Loop is a very important thing which we will require to solve numericals or to learn the Kirchhoffs laws. You will see in the numericals step by step. So now we are moving towards our main point, that is nothing but the Kirchhoffs law. So first we are going to see Kirchhoffs first law. This Kirchhoffs first law is also known as junction rule or Kirchhoffs current law. Don't forget the alternate names for this law because MCQs come from this point, that explain Kirchhoffs first law, or sometimes it is asked to explain junction rule or explain current law. So these are the alternate names for the first law. Don't get confused between Kirchhoffs first law and Kirchhoffs second law. So Kirchhoffs first law or current law is explained with alternate statements which have same meaning. So first statement, you can say that the algebraic sum of the currents at a junction is 0 in an electrical network. That is nothing but summation of current in an electrical network should be equals to 0. This is our first statement for Kirchhoffs law. Second statement, you can say that at any junction, the sum of current entering to the junction should be equal to sum of current leaving the junction. To understand this law, you can take a help of this diagram. It shows that three wires are connected at a junction, out of which two wires showing the current which is going inside the junction. That means it is going towards the point J. Current I1 and I2, it is nothing but the current which are entering in the junction, while the current I3 is leaving the junction. You can see it from the arrows shown in diagram. So as you know, I1 and I2 are currents entering to the junction, while I3 is the current leaving the junction. So what our statement says? Our statement says that at any junction, sum of the current entering to the junction should be equals to sum of current leaving the junction. So what will be the sum of currents entering to the junction? Yes, there are two currents entering in the junction. So their sum we can write as a I1 plus I2 should be equals to sum of current leaving the junction. Now there is only one current which is leaving the junction, so you can write I3. Suppose in case there are many currents which are leaving the current, so you can write down the summation of all these currents which are leaving the junction. So simply from this diagram, you can say the Kirchhoffs law or Kirchhoffs current law is like I1 plus I2 should be equals to I3. This is very basic example of Kirchhoffs first law. To explain this law doesn't take much time. Law can be explained within 5 or 10 minutes, but its application is little bit lengthy or procedure is little bit complicated. So you have to understand the procedure of applying Kirchhoffs laws. So this is about the first law. I hope everyone have understood the Kirchhoffs first law. Now there is one more question arising from this point, is nothing but on which basic principle Kirchhoffs first law or junction law is based. As the name of first law indicates, Kirchhoff's current law. Current means it is based on what? As we say in an earlier lecture, current is nothing but rate of flow of charge per unit time. So current is related with the flow of charges, right? So what law of conservation of charge says charge cannot be created, cannot be destroyed. It just can be transferred from one form to another form. So this is the basic working principle or basic principle on which Kirchhoff's current law is based. The very commonly asked question, on which principle Kirchhoff's first law is based, or on which principle Kirchhoff's current law is based. So your answer should be current law is based on conservation of charge. Now we are moving towards Kirchhoff's second law. Kirchhoff's second law is also known as loop rule, or it is also known as Kirchhoff's voltage law. So what the statement of law says? Statement is the algebraic sum of potential differences and electromotive forces in a closed loop is zero. Also you can say that in a closed loop, algebraic sum of change in potential should be zero. So here word closed loop is very much important. Unless and until there is a closed loop, you cannot apply Kirchhoff's voltage law. So in your statement of Kirchhoff's voltage law, closed loop word should be very important. Now let's explain this law. You can see the diagram where the circuit A, B, C, D, which is having resistance connected in each branch. So now if we start from the loop, considering the name A, B, C, D, A, what we can say according to our statement, in this circuit, summation of all the voltages should be zero. So here the word closed loop is very, very important. To satisfy this law, or to prove this law correct, this word is important, that loop should be closed. That means there is a change in potential in this circuit as the resistances are connected across the circuit, and if you are connecting a battery of voltage source V across any circuit and some resistance capacitance is connected in circuit, then there will be change in potential. So that change in potential can either be a gain in potential or it can be a drop in potential. You know, change means what? Change means it will be changed by increasing its value, or it can be changed by decreasing its value. So increasing the value is nothing but the gain, and decreasing the value we are considering here the drop. So we are considering two words like potential gain and potential drop. These words are very, very important in KVL. So now if there is gain in potential, so we are considering the sign for it is positive. So we are learning this under the point sign conventions. And if there is a drop in potential, there should be a negative sign. So what the statement of our law says, for a closed loop, summation of all the change in potential, that change can be positive, that change can be negative, like shown in diagram. VAB, potential across VAB, potential across BC branch, potential across DC branch, potential across AD branch. We don't know that potential change in potential is either positive, either negative. Doesn't matter here. If the circuit is closed, summation of all this potential must be zero. This is what our statement of Kirchhoffs laws says. How we can explain this law in very simple language? So you can consider an example by looking at this diagram. If you stands at A and covers the path A, B, C, D, A, so how, from where you start and where you reach? If it is closed loop, you are starting from A and you are reaching at A. So your position, final and initial position is same. So what will be the difference in potential if the final and initial position is same? Final position minus initial position is nothing but your potential difference. So your final position will be A. So you are starting from A, reaching to A. So how you can write the potential difference between final position and initial position, as the position is same? maybe the path is different but position is same. So va minus va will be how much? Will be 0. So that's what this law says. The change in potential should be 0, or summation of change in potential in a closed loop should be 0. So the word closed loop is very much important. As potential does not depends on path, it only depends on initial and its final value, the law specifies its statement. Now one more important thing we have to add in this law, that Kirchhoffs voltage law is totally depend on the principle of conservation of energy. So the question can be asked, on which principle Kirchhoffs voltage law is based or Kirchhoffs second law is based. So your answer will be conservation of energy. So don't get confused between the principles of first law and second law. Students always get confused between these two. So make it very clear, Kirchhoff's first law or current law is based on principle of conservation of charge, while the Kirchhoff's second law is based on principle of conservation of energy. So that can be two types of questions asked in a MCQ. Now this is about the Kirchhoff's first and second law. Now in next lecture we are going to see how to apply these laws. So we are going to write the steps or stepwise procedure to solve the numericals. First we are going to see the steps how to solve the numericals, and then we are going to solve some numericals for JEE, NEET and your board exams. So for having the information regarding next video, please subscribe the channel.